Let's do another example. How many grams of silver will be formed from 12.0 grams of copper, according to this equation? My known is the copper, I've got 12 grams. My unknown is the silver. Again, I want to calculate the grams. How many steps is this process going to be? Well, first I need to convert from grams to moles of this substance. That's going to be one step. Then I need to convert from moles of this substance to moles of a different substance. That's going to be one step. And then I'm going to convert from moles of this silver to grams of that silver, which is a third step. This is going to be a 3-step process. I'm starting with 12.0 grams of copper. I'm ending with grams of silver. This time I'm starting in this location and I'm ending in this location. I'm starting with a mass and ending with a mass. And this is going to be a 3-step process. Step 1 is using a molar mass to convert to moles. Step 2 is using a mole-mole ratio for converting between one substance and another. And the third step is using the other molar mass to convert from moles of chemical B to mass of chemical B. So let's leave room for 3 conversion factors this time and think about each conversion factor as we write it down. Step 1 is to convert from grams of copper to moles of copper. Get rid of the grams of copper, bring in the moles of copper. According to the periodic table, the mass of 1 mole of copper is 63.55. So I'm converting between grams of copper and moles of copper. The next step, now that I'm in moles, I can use my mole-mole ratio to change substances. I don't want my answer to be about copper, I want my answer to be about silver. So I need to switch from one substance to another. And the mole-mole ratio is, my mole-mole ratio is 2 moles of silver for every 1 mole of copper. Right now, my units cancel out with moles of copper and moles of copper. So right now I've got moles of silver, but I don't want to have moles of silver for my final answer. I want grams of silver. So I need to get rid of moles and convert to grams of silver. Using my periodic table, I can determine that 1 mole of silver has a mass of 107.87 grams. Those moles of silver cancel out, and I'm left with a big multiplication division problem. 12 times 1 times 2 times 107.87 divided by 63.55, also divided by 1 and also divided by 1. Be sure you're practicing putting these in on your calculator because students sometimes set up the problems correctly but don't do the math correctly. So make sure you're comfortable with what's getting multiplied and what's getting divided. The final answer is 40.7 grams of silver. Let's try another example. 1.20 times 10 to the 22 molecules of hexene undergo combustion to produce carbon dioxide and water. How many grams of carbon dioxide will be formed? So with this being a combustion reaction, hopefully you can write the balanced equation. Pause the video and try to figure out the correct balanced equation for the combustion reaction. Hopefully this is the answer that you got. Make sure that you know which is the known and which is the unknown value. Hopefully you correctly identified the known and the unknown values. Think about how many steps you think this stoichiometry problem is going to take, how many conversion factors we're going to need. Because we're starting with molecules, not moles, it's going to take us 1 conversion factor to convert to moles. Then it's going to take us another conversion factor to convert from moles of this substance to moles of a different substance. So that's going to take 1 conversion factor. And it's going to take 1 more conversion factor to go from moles to grams. So this is going to be a 3-step process. Let's check it out. If I start with 1.20 times 10 to the 22nd molecules of C6H10, and I need 3 conversion factors. 1, 2, 3. I need to think about what those 3 conversion factors are. I said I was going to convert from molecules to moles. How do I convert between molecules and moles? I need Avogadro's number. I need to think about how many molecules are in 1 mole of C6H10, C6H10, and that value is always 6.022 times 10 to the 23rd, always using Avogadro's number. That gets rid of molecules of C6H10, but I don't want my final answer to be moles of C6H10. I need to switch to a different substance. Remember, I'm trying to calculate grams of carbon dioxide. So I need to switch to moles of carbon dioxide. I need to get rid of moles of C6H10 and convert to moles of carbon dioxide. I do this using the mole-mole ratio in our balanced equation. I have 12 moles of carbon dioxide for every 2 moles of C6H10. Lastly, I don't want my final answer in moles of carbon dioxide. I want them in grams of carbon dioxide. So I need to get rid of moles and bring in grams, which is, I'm going to find out using the periodic table. 12.01 grams of carbon dioxide is the same as 1 mole of carbon dioxide. My units cancel out here. I'm left with grams of carbon dioxide, which is good. That's what I want for my final answer. And now we're left with a big multiplication division problem. Again, it's super important that you get comfortable with whatever calculator you're going to use on a test. Punch these numbers into your calculator and make sure you end up with the same final answer that I get here. If you do the practice of just dealing with the coefficients and multiplying and dividing the coefficients as you see here, 1.20 times 12 times 12.01 divided by 6.022 times 2, you're going to get 52.619. And then if you handle the exponents with the scientific notation, you'll do 22 minus 23 is -1. So you're going to get 10 to the -1. And that, because it's 10 to the -1, that's going to give you 5.2619. Okay, so I don't need scientific notation. Well, first of all, this would be times 10 to the 0 if I wanted to write it in scientific notation. You don't need scientific notation when you have a normal size number like this. Scientific notation is for really large and really small numbers. All right, so now I just need to think about sig figs. 3 sig figs for my initial answer. These numbers don't affect my sig figs. Avogadro's number would, the molar mass would, but those both have 4 sig figs. So this is my limiting number of sig figs, 3 sig figs. So I want to round my value off here. And my final answer is 5.26 grams of carbon dioxide. How many grams of tin 2 fluoride are produced from the reaction with 30 grams of hydrogen fluoride with tin? This is going to be a 3-step process because I'm wanting my final answer in grams and I'm given my initial value in grams. So let's determine what our known and unknown values are, or let's label them. Here I'm starting with hydrogen fluoride. I know I've got 30.00 grams of that substance, and I know I'm trying to calculate the number of grams of the tin 2 fluoride. So I'm going to start with my 30 grams of hydrogen fluoride, and I know I'm trying to convert to grams of tin 2 fluoride. So how do I convert from grams of hydrogen fluoride to moles of hydrogen fluoride? I need the conversion factor of grams to moles, and I write down the molar mass of hydrogen fluoride. which equates to 1 mole of hydrogen fluoride. The next step is to convert from moles of hydrogen fluoride to my other substance, in this case tin 2 fluoride. That uses the mole-mole ratio. I've got 2 moles of hydrogen fluoride for every 1 mole of tin 2 fluoride. My next step is to convert from moles of tin 2 fluoride to grams tin 2 fluoride. So 1 mole of tin 2 fluoride, using the periodic table, looking up tin and fluorine, adding those values together, you get 156.71 grams of tin 2 fluoride. Notice that these values, the units cancel out. Grams of hydrogen fluoride cancel out with grams of hydrogen fluoride. Moles of hydrogen fluoride cancel out moles of hydrogen fluoride. Moles of tin 2 fluoride cancel out with moles of tin 2 fluoride. 30 times 1 times 1 times 156.71 divided by 20.01, and also divided by 2. The number in your calculator looks like 117.47376, something like that. But our final answer is going to be rounded to 4 sig figs. Of the values that can affect the sig figs, 4 is the least number, so we'll round it off here, and we round off to 117.5 grams of tin 2 fluoride. Let's do one last example. Lithium nitrate reacts with lead 4 sulfate to form lithium sulfate and lead 4 nitrate. How many moles of lithium nitrate are needed to make 250 grams of lithium sulfate? Here's the balanced equation. I've labeled my known value and my unknown value. And because I'm calculating going from grams to moles, going from grams to moles of one substance takes 1 step. Going from moles to moles of another substance takes 1 step. But I want my final answer in moles. So this is only going to be a 2-step equation. So we start with 250 grams of lithium sulfate, leave room for 2 conversion factors, and I want my final answer to be in moles of lithium nitrate. And now I insert my conversion factors. My first conversion factor I need to convert to moles so that I can switch to a different substance. So I need to know how many grams are in 1 mole of Li2SO4. I'm going to need to use my periodic table to determine the molar mass of lithium sulfate, and I get 103.01 grams for my molar mass. And now I'm going to use my mole-mole ratio between moles of lithium sulfate and moles of lithium nitrate to convert for my final answer. Lithium sulfate has a coefficient of 2. Lithium nitrate has a coefficient of 4. So this is the correct setup to get me my final answer. 250 times 1 times 4 divided by 103.01 and also divided by 2. My calculator gives me the answer 4.8539, but I don't want 5 sig figs in my answer because my starting value only has 2 sig figs. This doesn't limit me, this doesn't limit me, this doesn't limit me. This one would, except it's got 5 sig figs, so it doesn't limit me either. It's this value that holds me back. I want to round off after 2 sig figs. Because this number is 5 or higher, I need to round up, and I get 4.9 moles of lithium nitrate. I hope this helped.